Behold, the James Webb Space Telescope's stunning first science images are here. The wait is finally over. NASA shared some of the James Webb Space Telescope's first breathtaking photographs and data from a live event on Tuesday, July 12. The 4 targets, which include 3 pictures and a spectrum, provide fantastic detail of the infrared universe. President Joe Biden released a 4th image, a finely focused ultra-deep field view, during a live broadcast on Monday, July 11, displaying a cosmos older than humans have ever seen. The photos and data demonstrate the telescope's enormous potential to contribute to scientific study and mark Webb's shift into an operational scientific instrument. The 3 photos published today show the Carina and Southern Ring Nebulas, as well as Stephan's Quintet, a clump of galaxies. The 4th target is the spectrum of WASP 96b, a gas giant exoplanet. The Carina Nebula is approximately 7,600 light-years distant from Earth and is one of the brightest and biggest nebulae in the sky. It spans over 300 light-years and contains Eta Carina, a fading supergiant star on the verge of a cataclysmic explosion, and Trumper 14, one of the youngest known star formation clusters. A nebula is a fantastic nursery, and Carina is a huge, dynamic, and occasionally violent one. This breathtaking view of the Carina Nebula's cosmic cliff gives fresh information about this huge star nursery. For the first time, we can see fresh new stars that were previously concealed from our perspective. The Southern Ring Nebula, on the other hand, is far closer to Earth, at 2,000 light-years distant. A planetary nebula is an expanding cloud of gas that surrounds a dead star. The dying white dwarf star at the nebula's center is unimaginably hot and emits powerful ultraviolet radiation, which causes the gas surrounding it to flare up. During the ceremony, Carl Gordon, an astronomer, noted that the new photographs reveal the shells formed by that gas, as well as regions in the nebula where starlight shines through. As we get towards the center, we see a surprise for us, which is, we knew this was a binary system, but we couldn't see much of the actual star that formed the nebula, but now in Miri, this star glows red because it has dust surrounding it, so in Miri, we got to see both stars very well. Stephan's Quintet is a collection of 5 galaxies that look absurdly close together, around 290 million light-years distant from Earth. 4 of the galaxies are entangled in a cosmic dance that will eventually lead to the foursome merging, and 3 have elongated, spiral-like structures as a result of their interactions. The Quintet stars range in age from newborn to old, encompassing hundreds of millions of years of cosmic history. This is a really significant image and location to examine because it truly illustrates the sort of interaction that drives the growth of galaxies. The last element of Webb's first published science results was a spectrum, a depiction of the number of different wavelengths of light emitted by WASP 96b, an exoplanet. At nearly 1,150 light-years distant, the gas giant world, almost half the size of Jupiter, is the nearest of the newly discovered objects. It circles its star every 3.4 days and has a distinctive, cloudless atmosphere composed primarily of sodium. WASP 96b, the only known cloudless planet, has been a mystery and a great subject for future research since its discovery in 2013. And Webb's new data provides scientists with more information about that odd environment than they have ever had before. We've been able to investigate exoplanet atmospheres in the infrared with other telescopes, but not to this degree of detail. This is only one sliver of data that Webb is sending us, especially with the NIRISS sensor. What you're seeing are bumps and wiggles that suggest the existence of water vapor in this exoplanet's atmosphere. The stunning new photographs come after 7 months of meticulous telescope setup following its launch on December 25, 2021. In turn, the launch culminated more than 2 decades of work, beginning in 1996, and widespread conversation about the project began far earlier. Webb was occasionally poorly underfunded throughout the years and was even on the verge of being cancelled owing to rising expenditures. Despite the bumpy route, experts say that now that Webb is in orbit, the telescope, which is operating better than planned in nearly every area, should be able to operate for the next 2 decades. The spectral data of WSP-96b was collected by Canada's Near-Infrared Imager and Slitless Spectrograph (NIRISS) instrument, which will allow Webb to perform critical investigations of distant galaxies and exoplanets during the telescope's career. Though most people envisage a single mission control center for every particular space operation, Webb has numerous teams controlling it from various places, and officials from each agency assisted in the selection of Webb's initial photographs. In the days leading up to the publication of the initial photos, some astronomers expressed mixed feelings on Twitter, as enthusiasm for the new data mixed with a distaste for the moniker. Since the spring, when authorities claimed that a study into Webb's participation in the Lavender Scare was continuing, NASA officials have not addressed the name of the observatory. Whatever it is called, the telescope is about to make history. On Monday, July 11, the final instrument was certified for science, just hours before Biden announced the ultra-deep field. Now that the space community has celebrated the observatory's first anniversary, Webb will dive into its scheduled science observations, and scientists will be able to evaluate data from Webb's initial targets immediately away. As study begins on every imaginable scale in our universe, from our solar system to the very earliest galaxies, startling new ideas might begin to flow swiftly. Whatever we discover, Webb scientists regard today as the beginning of a new era in which Webb will change what we know about our universe and how we think about our role within it. Every dot of light we see here is a single star, similar to our Sun. Our Sun, planets, and eventually us were produced from the same substance that we see here. Now let's compare the JWST data with that of Hubble's. On July 11, 2022, history was made as the very first science image from the James Webb Space Telescope was unveiled to the world. Upon its release, it immediately broke the cosmic record for the deepest view ever taken of the universe, an incredible achievement. This record had previously been held by the Hubble Space Telescope, which first set the record back in the mid-90s with the original Hubble Deep Field, and which broke its own record numerous times over the years. When comparing Webb's first image to similar images taken by Hubble of the same patch of sky, however, you can see just how much more detail Webb's camera is capable of capturing. So what are we actually seeing in this new deep field image? And how much more is it revealing of the universe? Before we get stuck in comparing the images, let's first get a basic overview of how each of the telescopes differs. Because their capabilities are not identical, Webb often gets called the replacement for Hubble, but NASA prefers to call it its successor. Webb will primarily look at the universe in the infrared, while Hubble studies it primarily at optical and ultraviolet wavelengths, though it also does have some infrared capability as well. Both Webb and Hubble are reflecting telescopes that conceptually work the same. Light reflects off a large primary mirror onto a secondary mirror, which sends it back through a hole in the primary mirror and into science instruments for analysis. Hubble's mirror is 2.4 meters wide, which is 7.9 feet wide, whereas Webb's segmented honeycomb-shaped mirror is an enormous 6.5 meters across, which is 21.3 feet across. Webb has the largest mirror ever flown in space. Its 18 segments are made out of lightweight beryllium and coated with a thin layer of gold, making it much more sensitive to infrared light, allowing it to peer farther back into time than Hubble is ever capable of doing. The two telescopes also have very different cooling requirements and are in very different positions. Hubble is in orbit around the Earth, while Webb views the universe from 1.5 million kilometers away, which is about 1 million miles away. A location called the second Lagrange point. Image comparison. So now we know a little more about how each telescope differs, let's have a look at the images, and straight away, you can see how the greater capabilities of Webb have allowed for a much more detailed view of the universe. Each photo is of the galaxy cluster called SMACS 0723, which is located 4.6 billion light-years away. This area of space is particularly interesting for astronomers as the galaxy's gravitational pull distorts the light of more distant galaxies behind them, a phenomenon known as gravitational lensing. Thanks to gravitational lensing, Webb is actually able to look much farther away. This is why some of the light from those distant objects seem curved and warped. NASA says that the light that Webb senses is more than 13 billion years old, which means the galaxies in the background were formed just a few 100,000 years after the Big Bang. For the first time, we can see some of the faintest objects ever observed in the infrared, and what is incredible is that this photo only covers a patch of sky approximately the size of a grain of sand held at arm's length by someone on the ground. Compared to Hubble's view of the same area, Webb has brought those distant galaxies into sharp focus. Many objects that appeared as faint smudges to Hubble now can be seen in crisp view. Because Webb peered so far into space to capture this magnificent image, it was able to observe distant light that's been traveling across the cosmos for billions of years. As a result, closer galaxies are seen in the cluster. SMACS 0723 appear as they would have 4.6 billion years ago. This photo is just one of 5 that are being released, offering our tiny blue planet a glimpse into the distant past. In the coming years, Webb will no doubt build on the legacy of Hubble, allowing us to see deeper into space than ever before. Although the best is yet to come, each new observation, especially at this early stage, reveals a brand new page in a 13.8 billion-year-old cosmic story. The universe will never be the same again.